All right, if we take a look at number 5, our lowest common denominator, because these are already factored, is going to be x plus 1 and x plus 2. And you want to be careful on this one because we have subtraction here. So we're going to have to make sure we apply that negative to the 3 when it's time. All right, so each fractions, or each numerator, is going to gain an x plus 1 and an x plus 2. Now when you get to the right side, don't forget it. Sometimes people in this scenario forget to multiply this fraction by x plus 1 and x plus 2 because there's not a fraction up here. But remember, whatever you do in this to an equation, you have to do it to all of its terms. So even though it's just a 1 on the right side, we have to put the x plus 1 and the x plus 2. Alright, so now we can go through and cancel. So notice each numerator has just gained the x plus 1 and x plus 2. But we need those there so we can cancel out. Now, we've actually kind of created more of a mess over here, but we'll deal with that in a second. With what's left here, we have a 4 times x plus 2. So go ahead and distribute that out. So I have 4x plus 8. Now here, like I said, don't forget we need to apply this negative. So we're going to treat this like a negative 3. So when we distribute it, we're going to have minus 3x minus 3. Okay, and then on the right side, these ones cancel each other out essentially, but they don't really, they just simplify. And then we're going to distribute this. So x squared plus 2x plus 1x plus 2. All right, we need to combine like terms on the left. All right, so we have 1x plus 5 is equal to, and on the right side, x squared plus 3x plus 2. Okay. All right, now we have a mismatch of powers, so we want to get everything to one side. So we're going to subtract 1x from both sides.
I want to see. Can I please do it?
Hazel, I don't think you know how to do this yet.
What?
I don't think you know how to do this yet, sweetie.
How do I not know how?
Well, you're not quite old enough. All right, so that's Hazel, everybody. So we set this equal to 0.
Mommy, how could you talk stuff right?
Okay, so we have 0 is equal to x squared plus 2x minus 3. And then we can go ahead and factor this. We're looking for a pair of numbers that multiply to give us negative 3, that add to give us, positive 2. So it's going to be plus 3 and minus 1. So when we solve each of these, we're going to get x equals negative 3 and x equals positive 1. And if you store both of those values for x and check them, they both work, and you can double check here. If I plug in 1 here, it's not going to cause this denominator to be undefined, nor will the negative 3 in either of those. So if you store those for x, which I would recommend you do, you can double check those. Okay. All right, so let's go ahead and take a look at number 6 while we're here, and make sure you factor this denominator. All right, so it's going to factor into x minus 3 and x minus 4, which is good because that's what we had in the other two denominators. All right, so everything's going to need to get multiplied by x minus 3 and x minus 4 up top.
Look at my work.
Oh, Hazel, that looks great. All right, so we have an x minus 3, and x minus 4, all over an x minus 4, plus a 6, x minus 3, x minus 4, all over an x minus 3, and then a 16. I'm going to cheat a little bit and just put those so I don't really have space. The reason why I'm doing that is I know that the x minus 3 and the x minus 4 are going to cancel out the 2 that are on the bottom, and all I'm going to be left with is a 16 up there, so that's why I did that. All right, so back to over here. These x minus 4s are going to cancel out, and the x minus 3s are going to cancel out. So if we go ahead and simplify, we'll have x squared minus 3x.
This is for Daddy.
Oh, thanks, Hazel.
Because I draw the picture of him.
That's nice. Here, let's show my students. That's cute. Draw a picture. Draw a picture of me.
Can I please show it one more time?
Sure, you can show them. Thanks, Hazel. Okay, draw a picture of me. And then you can show my students that. Okay, move your arm. All right.
And me.
Okay. So we're going to distribute this 6. So we'll have 6x minus 24.
No, I'm going to do you with that.
Okay. Is equal to 16. Again, because the x minus 3 and the x minus 4 that we put up top would cancel out the 2 that we factored into the bottom. Okay. All right, so we got to combine like terms. So we'll have an x squared, a plus 3x, and then if we move this 16 over, let's see here, negative 24 minus 16 is going to give us negative 40. Okay. And then we can factor. So we're looking for two numbers that multiply to give us 40, that add to give us, or negative 40, that add to give us 3. So it's going to be plus 8. And minus 5.
You with a ponytail.
Oh, thank you. So x is going to equal negative 8. Okay, hold on, Hazel. I'm almost done with this question, then you can show them. And x equals positive 5. And if you go back to the beginning and store a value for x, if you store both of these and check it, I promise they work.
Can I please show it?
Yep, here's a picture of me by Hazel. That's me.